All right, so I'm going to try something a little bit tricky here. We're going to try and create a 4-bit adder circuit so that we could actually add together 4-bit numbers. So what I'm going to do is I'm just going to start by creating this here. That's going to be basically my number 1, and this will be my number 2. So in theory, I want to be able to create circuitry here, which will add together and work from there. Now, let's build it as we go along and try and explain it. I actually have under the miscellaneous section, which you won't be able to see, a device which actually does all the adding together for us, so we don't have to build the full adder like we did in the last particular section. And this is very handy. So I'm going to join that one together with that. And I'm just using these two here. Now note as I put my mouse over them, it does say A and B. And then what I'm getting here is output is the sum and then the carry out. That's what the C out stands for. So I'm just going to put a globe up here. I'm going to do a little bit tricky with this. I'm going to go right over to here to try and something make sense. I'm going to join up that to there. So let's just see if that's working. If I join one of them together, it should be yes. That's be right. So basically 0 plus 0 gives me 0. And then if I flick one of the switches, it should turn it on. But if both of them on, it should give me the answer of 2, which means something's going to come out of this carry out here. So let's see what we can do with that then to see if that makes sense as we do it. So I'm going to grab another full adder and put that here. I am going to join the carry out to the carry in, which is the third one of these here. Now, it probably doesn't actually really matter if I do that fully right. I'm going to do that there and go across. And I'm going to grab this one from down here. Just trying to get my angle right so I get this in right. And I'm going to join it up. Now, I'm glad I'm doing this gradually for you to see it as we go along. What we've got here now is we've got 2 bits coming in. We've got a second answer, so I'm going to grab my second output light. I'm going to put that over here, and I'm purposely building this so hopefully when we finish it, it will make sense in how these are wired up. So let's just have a look here. These are my 1s, this is my 2s column. So let's say at the moment it's 0 plus 0, and I'd expect the answer to be 0. I'm going to make this 1 plus 1. And so the answer is telling me in the 2s column, that switch is on and this one is off. So let's just label it a little bit. This might take a little while to do this, but this is going to be our 2s. This one here is going to be our 1s. So if the light gets turned on, it adds it to it together. So over here, 1 plus 1 gives me 2, which is what we'd expect. Let's go 1 plus 1 here. And that's not working where we'd want it to, but we'd expect that to give us 3 plus 1 gives us 4, and that's not there yet because we haven't wired up enough lights for us to see that. That makes sense. But let's go 2 plus 1. So the 2's column is on here, the 1's, and that gives me 2 plus 1 gives me 3. So let's see if we can finish wiring this up. Grab another half adder. Going to grab the carry out. And it makes sense wire that up to the carry in. I'm going to grab this one here. You can see there's a bit of an art form in trying to get these to connect up properly. And I'm going to grab this one here. Join that up to there. And bring that in there. So similar thing again. I'm going to grab myself another light. Put that up here. This in theory should be my 4's column. So I'm going to join this up to here. All right, that gives me that there. And then once again, hopefully now I've got the capacitors. So let's have a look at this. This is still currently set to 2 plus 1. Let's try and set it to be 2 plus 2. And that's now giving me, exactly as I hoped, my 4's light is now turning on. So as I play with the different combinations over here, this is how the circuit will work. So at the moment I have 0, 0, 0, all zeros. Let's go 2 plus 3 and gives me 4 plus 1. All right, so just one more of these full adder circuits to bring in. I'm going to bring that in over here. Once again, I'm going to grab the carry out straight away. We're going to join that into there. And I think I made a small mistake, so let's just delete that. Let's delete the cabling, which is causing me problems. Just join that up to there. All right, so that's that particular one there. I'm going to grab this. Once again, art form to make sure that we wire them up correctly and also that it can be understood easily. So I'm going to do that there. I'm going to bring that up through the middle and just a little joiner there. So I've got those ones there. Once again, I'm going to grab one more output light. And I'm going to label that to be the 8s. So now truly I do have a 4-bit adder. I'm going to bring this cable up to here. And then I'm going to have still a leftover at the end, which I'm going to call my carry out. And I'm going to grab one more light down here. And this will basically indicate when what we've tried to add together isn't possible to do within this particular number system. So let's go back here. I want to set this to be, let's say 6 plus 3. 6 plus 3, they're telling me there is an error here. I'm not sure exactly why I have an error. All right, that's 6 plus 6, 6 plus 2. There's a connection error, which I've got to somehow try and work out where that is. I'm wondering if that's here that the connection error is. Let's see if we can just replace that cable there to that one. I still think there is a connection error here, so I'm just going to really try and delete the bits that I don't have here. Let's pull that out from there. And then down, and then across. And it's still telling me there is a connection error, so I'm just wondering why that's causing me the problems there. As I put these together, I would have hoped that 3 plus 6 gives me 9, but the 8 is not working for some reason, and I think it's connected to this carry stuff down here. If I delete that here. I have the 2 parts coming in, and I need the carry out. Let's just maybe move these across a little bit here and try and drag it down there, bring it down to there, and that last connection there. And once again, I'm getting an error, so I'm just going to delete that part, bring in another adder into here. Join that up to there. That one seems to be working from that point of view. Join that one there. That one seems to be working there. Join that one up to there. And then this one here comes across to there. And in this case, it does seem like that I have been able to solve the problem. And I know I probably could have saved you having to watch all that, but it's good just to see how the troubleshooting can work in this. So coming back to here, we have 6 plus 3 gives me 8 plus 1. 6 plus 3 is obviously 9, and that's how it digitally would work. We can continue to go here. So at the moment, I've got 7 plus 6, and that gives me 13 is the right answer. And then obviously we're going to hit some problems. I've got 7 plus 7 gives me 14. That's okay. But what happens if I actually go for 15, and there is a carry here which says that we've exceeded the numbers that we can actually show in this, and that's a really helpful thing. While I know that's taken a while to do the full adder, I think you'll appreciate that it's actually quite an effective way of explaining how the binary number system works together.